If you've been following the channel for any length of time, you know that one of my favorite topics is Planet 9, the hypothetical ninth planet in the solar system. And every now and then, we get new results from teams searching for this mysterious world, and they always interesting. This time, I think we can say that things have gotten really interesting indeed, because we have a new paper published by an entirely new research team with some very intriguing claims. So let's talk about what's going on. It's me, and you're watching this channel. This is a space news channel. The idea of a ninth planet in the solar system has captured the imagination of astronomers for decades. Even before we had discovered Pluto, there were suggestions of a large planet out beyond Neptune, and it was only after its discovery in 1930 that we started to rule out such possibilities. But even so, many astronomers still suspected that something large was out there. In 2016, two astronomers revived the idea and suggested that there could be a planet around 10 times the mass of Earth orbiting the Sun at a distance of 400 astronomical units, or 60 trillion kilometers. That's far beyond the orbit of Pluto, which sits at about 40 astronomical units from the Sun. The claim was based on computer simulations that showed that if there was a planet of that size in that region, it would explain the strange clustering of orbits seen by several minor planets in the Kuiper Belt. However, despite several searches, the planet has yet to be found, and more importantly, no one has been able to confirm or deny the hypothesis. Nevertheless, the idea has remained popular among astronomers, and there are plenty of people who continue to argue that such a planet must exist. The reason why this is important is that if we can find it, then it will help us understand how the solar system formed and evolved over time. It could also tell us whether or not there are other planetary systems out there that have similar structures. Now, the problem with finding Planet 9 is that it is so far away. It would take a lot of time and effort to search for it, even with the most powerful telescopes in the world. Not to mention that it would appear very dim because it is so small compared to the Sun. The good news is that astronomers are up to the task. They have developed sophisticated methods to detect the planet's gravitational pull on other objects in the solar system. For example, by measuring how fast these objects move around the Sun, they can work out their masses. If they find that some of these objects have masses that are much larger than expected, then it could mean that they have been pulled in by Planet 9's gravity. Another way to detect Planet 9 is to look for changes in the brightness of nearby stars as the planet passes in front of them. By measuring these changes, astronomers can work out the planet's size and orbit. Finally, there is the possibility of using gravitational microlensing to detect Planet 9. This technique works by looking for the brief increases in brightness that occur when a massive object passes between us and a background star. These are just a few of the methods that astronomers are using to try to find Planet 9. And given the fact that there are so many different ways to do it, it seems likely that we will eventually succeed. And as it turns out, we already have some hints that Planet 9 may exist. In 2020, for example, a team of astronomers reported that they had found 6 objects in the Kuiper Belt whose orbits were clustered in a way that could not be explained without invoking the presence of a large planet. More recently, another team claimed to have discovered a 7th such object. What is interesting about this latest discovery is that it comes from an entirely new group of researchers who used a completely different method than the one used in 2020. You see, in the previous study, the team relied on computer simulations to estimate the likelihood of such clustering occurring by chance. However, in the new study, the team instead looked at actual data from the Outer Solar System Origin Survey, also known as OSO. OSO is a project that aims to survey the outer regions of the solar system using the Subaru telescope in Hawaii. The survey began in 2014 and is expected to be completed in 2024. OSO uses a wide-field camera called the Suprime Cam to image a large area of the sky in a single field of view. This allows the telescope to quickly scan large areas of the sky, making it ideal for searching for faint objects like comets and asteroids. As part of the survey, the Subaru telescope has imaged over 1,000 square degrees of the sky in 6 different filters. This has resulted in the discovery of thousands of new trans-Neptunian objects, or TNOs, which are icy bodies that orbit the Sun beyond the planet Neptune. In the new study, the team focused on a sample of 1,550 TNOs that have been well characterized. This means that the team had accurate measurements of their positions and brightness. Using this data, the team was able to calculate the clustering strength of the TNOs. Clustering strength is a measure of how close together a group of objects are in the sky. A high clustering strength suggests that the objects are grouped together, while a low clustering strength suggests that they are randomly distributed. The team then compared the clustering strength of the TNOs to that of a set of simulated TNOs that were created using computer models. The simulations assumed that the TNOs were produced by the gravitational collapse of a disk of gas and dust that surrounded the young Sun. The simulations also took into account the effects of giant impacts and the migration of Neptune on the TNOs' orbits. The team found that the observed clustering strength of the TNOs was significantly higher than that of the simulated TNOs. This suggests that something unusual is going on in the outer solar system. The team concluded that the most likely explanation is the presence of a Neptune-sized planet with a highly eccentric orbit. Such an orbit would cause the planet to pass through the inner solar system every few hundred million years or so, where it would gravitationally sculpt the TNOs into their observed configuration. The team estimates that the planet's orbit has a semi-major axis of 270 astronomical units, or 40 billion kilometers. It also has a high eccentricity of 0.8, which means that it comes very close to the Sun at times. These results are consistent with those of the 2020 study, which estimated that Planet 9's orbit has a semi-major axis of around 370 astronomical units, or 55 trillion kilometers. However, there are some differences between the two studies. The team in the new study found that Planet 9's orbit is less inclined relative to the Sun, meaning that it doesn't dip as far south or north as the one in the 2020 study. Additionally, the team in the new study found that Planet 9 is more massive than the one in the 2020 study. They estimate that it has a mass of around 10 times that of Earth, whereas the team in the 2020 study estimated a mass of 5 times that of Earth. Despite these differences, both studies agree that there is something unusual going on in the outer solar system, and that the most likely explanation is the presence of a large planet. So what does this all mean? Well, first of all, it's important to remember that these are just 2 studies, and more work is needed to confirm their results. Additionally, there are other possible explanations for the unusual clustering of TNOs. For example, it could be that Neptune had a more significant impact on the TNOs than is currently believed. Or it is possible that the TNOs were never in thermal equilibrium with the Sun, as assumed in the computer models. However, if future studies are able to confirm the results of the 2020 and 2023 papers, then it would be very exciting. It would mean that there is strong evidence for the existence of a large planet in the outer solar system. It would also suggest that the solar system is more complex than we currently understand. The search for Planet 9 is one of the most exciting developments in astronomy in recent years, and it shows no signs of slowing down. With new surveys and more powerful telescopes coming online all the time, we are sure to learn more about the outer solar system in the years to come. If it turns out that Planet 9 does exist, then it will be one of the most important discoveries in our lifetimes. If you want to learn more about this topic, I recommend checking out a video that I made on the Planet 9 hypothesis back in 2017. I think it gives a good overview of the topic and will help you to understand the latest developments. And if you want to support my work, please consider becoming a patron. Your support helps me to continue making great videos. Thanks for watching.